Okay, here we go. So I think I'm gonna update grades for the first time, getting the grade book set up. There's only one assignment in there, but just, check that out. Make sure everything's correct. Does everybody know how to access, I've got the assignment set up so that, I can't remember what I talked about in each class. I've got, you know, all these different classes. I kind of get off track in all of them, but at the risk of having said this before, remember that the due dates are important, right? It's important to really try to stick to those. But I also recognize that things happen. You guys are busy, you're involved in activities, so every once in a while something is going to slip a little bit, and I get that. You don't want to get behind too much. If you do, I mean, that really doesn't work in a class like this. But every once in a while things will slip. Just get caught up as quick as you can to kind of help you along, and in keeping with that philosophy. If you miss a deadline, you still can go in and do the assignment and get full credit. Do you know how? Do you know how to go in and access an assignment once the due date is passed? Anybody know? Maybe you haven't had to do that yet. So if the due date's passed, like on this first assignment, let's say you're almost done, but you want to go back and try to finish it up, you can do that. You go don't go to grades. When you log into your My Math Lab account, there are all those tabs on the left side. If you go to grades, it'll just show you everything you've done, and you can go in and review anything that you've turned in, a long time ago, even tests also. Once you've taken the test, you can go in and review it and see what your answers were, what the correct answers were. But if you want to continue working on an assignment when the due date is passed, you go into homework, hit the homework tab, and when you go to that assignment, there will be an option to improve. I think it's improve my score or something like that. Improve score, improve my score. If you click that button, it gets you back into the assignment, and you can go in and continue to work on it, right? And everybody knows, I'm sure by now, that you can always go in and reload problems after you've tried it gives you all these checks, and after the final check, it'll give you a grade on that problem. If you don't like it, what do you do to fix it, to get 100% on that problem that you missed? Yeah, just similar question. Hit the similar question button, it loads up another one which you can do for full credit. Okay, make sense? Has everybody found the resources, like the Help Me Solve This and the View an Example? You know where to find those? Okay, good. So one thing, did I talk to you guys about splitting your screen when you're doing homework? Okay, I think that's a really good idea. To split, I know they're kind of small screens on the Chromebooks. I think the charging issue with the Chromebooks is fixed, hopefully. I guess we'll see. But when you're doing your work, open up one big window that's like 3/4 the size of the screen to be working on the assignment, and then another 3/4 size window that's 3/4 of the screen, but it's kind of offset, so you can always click between the two. One of them is for all the resources from my Google Classroom. Maybe open up your textbook on there also, so you can be looking at those resources while you do the homework, and then the other screen would just be the homework screen. Does that make sense? I think that's a great habit to get in. It really is very helpful. Questions? Comments? Okay, today we're going to wrap up the last section of Chapter 1. I'm not going to do a test over just these 3 sections, just because I feel like there's not that much stuff there. We'll go ahead and add another section or 2 after Roundup, and then we'll do our first test. I'll give you a review assignment. We'll talk about that after Roundup. But this is just a little more kind of, Algebra 1 level review stuff. Maybe filling in a few blanks, things you didn't cover in Algebra 2. So today we're going to talk about the properties of real numbers. I don't want to get into this in too much depth, but I want you to be familiar with them because they come up again and again in math. And even though these seem pretty simple, these properties, very intuitive, pretty obvious, there are some important extensions. If you go on and study math beyond Algebra 2, which I hope you all do, when you get into things like in college, it'd be a class called linear algebra and matrix theory, where you talk a lot about how to solve linear systems using matrices. It's a really cool class, very important if you're going to go on and do anything with math or math-related fields in science or engineering or something, or economics or something like that. But all these properties that are so simple for real numbers, you could apply in other situations in math, like to these big, strange-looking things called matrices. a matrix in math is. We'll take a little look at that maybe, but we're not going to do very much. I'll just introduce you to the idea so when you see it later in your lives, it won't be such a shock. But all these properties that are so simple with these real numbers, you can extend to other places in math that aren't so obvious and aren't so simple. So it's kind of important to know what they're all about. So what are they? There's really not very many of them. The first ones we'll talk about are the commutative properties. So the commutative properties are really simple. If we're talking about real numbers, A and B. So A and B just represent any real numbers. The commutative property of addition just says that A plus B equals B plus A, right? Makes sense, doesn't it? I mean, 3 plus 5 is the same as 5 plus 3, isn't it? Right? It doesn't matter the order in which you add up two numbers. The result is the same. Same thing is true for multiplication. A times B is equal to B times A. So how can you remember that? I mean, this is the lowest level learning we ever do in school is memorization. Super low level learning. It's not hard to do. It's easy, you know, it's low level learning. It's easy to get, but it's also easy to forget, right? So how can you remember this? How can you hang on to this? Well, what does it mean to commute? Like, think about this. Your parents commute to work, right? So what do? They exchange their places, right? Don't they? They go from home to work when they commute in the morning, and then in the evening when they go back home, they commute back home. That means they just exchange positions, right? Work and home. That's what it means to commute in math, is to exchange places. So the commutative property says that we can exchange the places of the two things that are being added or multiplied. Doesn't matter. They're still equal, okay? Give me thumbs on that. Does that make sense? Okay. Notice though, there's a really important caveat here. This property and all the other ones we're talking about today work for addition and multiplication, but what about the other operations? Does the commutative property hold for subtraction? Is 17 minus 5 the same as 5 minus 17? It's not, right? So it doesn't work for subtraction. What about division? Is 20 divided by 5 the same as 5 divided by 20? No. Okay, so you got to remember that. These things only work for addition and multiplication, but not for subtraction and division, okay? So that's the commutative property. Next one is the associative property. So how do they look similar. They both, we're looking instances where we're adding stuff and multiplying stuff, but look at the differences here in the associative property from what we just talked about. The associative properties for addition and multiplication only apply when you're adding or multiplying more than two things. And really all this is saying is that if we're going to add up a bunch of numbers, let's say, we have to always add numbers in pairs. You can only add two things at a time. And so you have to choose the order in which you're going to add up multiple things, more than two things. So the associative property of addition says if we have three numbers, A, B, and C, that we're going to add up, we could, for example, add the first two, A plus B, get a result, and then add C. That's fine. Or we could add B plus C first and then add that to A. It doesn't matter. The order in which we pair up those numbers to add them doesn't make any difference for addition or multiplication. How do you remember this? Well, what does it mean to associate? Who are the people that you mostly associate with? Family and friends maybe, right? If you're an athlete, maybe teammates, stuff. So what does that mean, to associate? That means to group yourself with, right? You group yourself with the people that are, you spend the most time with, your friends. Does that make sense? So to associate is just to group. If you look on the front of a law office and it says, I don't know if it says Jones and Associates on the law office, what's that mean? Well, those are all the attorneys that group themselves into that law office. So to associate is to group. We can group addition and multiplication any way we want to if we're adding or multiplying multiple things. Is that for me? Awesome. Thanks. Oh, gotcha. Okay, you're good. Okay, so does this work for subtraction and division? Well, what do you think? Probably not, right? I kind of already gave you a hint it doesn't, but let's just show that. What if I've got these three numbers that are being subtracted, 8 minus 3 minus 15? The order in which I group those does make a difference. If I group the 3 minus 15, well, 3 minus 15 is negative 12. 8 minus negative 12 gives me 20. What if I group them differently? What if I group the first two numbers? 8 minus 3 gets grouped. So 8 minus 3 is 5, and then I subtract the 15. I get a different result, right? So again, the associative property works for addition, works for multiplication, but does not work for subtraction or division. The order in which I divide multiple things also makes a big difference, right? Can you give me thumbs on that so far? How are we doing? Okay, good. All right, so those are first two. Next one, I'm not even going to talk about. You guys have done this probably 1,000 times, and it's no big deal. You guys know how to distribute. If I'm multiplying a number times a sum or a difference, times things that are being added or subtracted in this case, doesn't matter, right? If I'm multiplying a number times a bunch of stuff that's being added or subtracted, all I have to do is distribute that number. We call it a coefficient, right? Because it's being multiplied by stuff. I just distribute that coefficient to all the parts. You've done that many, many, many times. That one we don't even have to spend any time on. You know it inside and out. Okay, last two, the identity and inverse properties. Okay, so these are very simple, but I want to make sure you understand the theory behind this. What's the concept? Of all the real numbers, infinite number of real numbers, right? The two that are probably the most important to us, that we use the most often, are 0 and 1. They're really important. 0 is important because it's the only number that I can add to something and not change it, okay? So we'd say when we add 0 to a number, we preserve the identity of that number. The identity stays the same, doesn't change. For multiplication, that number is 1. 1 is the only number that I can multiply by something and keep it the same, preserve its identity, right? So for that reason, those are important numbers. We give them special names in math. We call 0 the additive identity, because it keeps the identity the same when you're adding. And we say that 1 is the multiplicative identity, because again, that's the number we can multiply by and keep the identity the same. And so here's the identity property of addition. It just says this, very simple. It just says that if A is some real number, then A plus 0 equals A. Stays the same. Very simple, okay? Notice that what's key here is that we're using that 0. We're adding the additive identity 0 to something, and it doesn't change. Well, what do you think the identity property of multiplication is going to be for the real number A? What do you think? Okay, what about 1? The identity property of addition says A plus 0 equals A. What do you think it's going to be for multiplication? A times 1 equals A. There you go, you got it. That's it. There's the identity property for multiplication. And again, notice that what's important here is that number 1. We're multiplying by 1 to keep the number the same, to preserve its identity. Okay? Give me thumbs on that. Does that make sense? Pretty straightforward, right? Okay, so now these two properties, I call them the I properties because they both start with I. They go together. The inverse properties are related to the identity properties. The inverse properties just say, okay, 0 is my special identity number for addition. What would I have to add to the real number A to get 0 as my answer? Okay? And here's what we find. Oops, don't want to do that. Don't do that. So the additive inverse is what we add to something to get 0. Really, that's just an opposite. That's all that means. The additive inverse for us is the very same thing as the word opposite. The additive inverse of A is just the opposite of A, which would be negative A. To find an opposite, don't I just multiply that number by -1 to get its opposite, right? Okay, so then that gives us this property. I gotta go down. I think it's right here. There's the inverse property of addition. Just says this: A plus its opposite negative A equals 0. Okay, so this time the result of the inverse property is that we get that special number for addition, that identity number for addition, 0. See how they're related? Okay. What do you think? Okay, so that one might have been pretty obvious, right? We know that to get 0, we would add negative A to A. What about for multiplication? We're going to use the same pattern, right? We want to get our special identity number for multiplication, which is 1. We want to get that for our answer. What would I have to multiply A by to get 1? Think about that. What would I multiply 2/3 by to get 1 for an answer? If I multiply 2/3 by 1, I just get 2/3. Think about that. When you multiply fractions, we multiply straight across, right? So, whoops, bad color. 2/3 times something has to equal 1. 3/2, exactly. Yeah, good. Right? How does that work? Well, if I multiply straight across, I get 6 on the top and 6 on the bottom. That's just 1, right? Okay, what do we call that? How is 3/2 related to 2/3? 3/2 is the what of 2/3? Not opposite. Opposite means like negative versus positive. What do you call that word? Well, okay, so it is the multiplicative inverse, you're right, but we have kind of an easier name for it than that. That's a mouthful, multiplicative inverse. You guys have said this before in your math classes. I think we maybe even said it last week in here, maybe once. What do you call that? What's the flip of something? Starts with an R. Not reverse. What is it? Reciprocal. That's it. There you go. That's it. Good. Okay. So, yeah. So look at this. Now we've got another name for the multiplicative inverse would be the reciprocal. Why is it the multiplicative inverse? Because remember what the inverse's job is. It's what we're going to either add or multiply the original number by to get the identity number as the answer, right? So for us to get 1 for an answer, when we multiply, we're going to multiply A by its flip or its reciprocal. Okay? Not so bad, right? That's it. That's all the properties we're going to deal with. So let's summarize all of these on one page. There they are, right? So we've got the properties on the left, and then we've got for addition and for multiplication, what do they look like? Well, the commutative property, remember, A plus B equals B plus A. Commute means to exchange. A times B equals B times A. The associative property is when I'm adding or multiplying more than 2 things. The order in which I group the things that I'm adding or multiplying is irrelevant, doesn't matter. So A plus the quantity B plus C is equal to the quantity A plus B plus C, okay? A times the quantity B times C equals the quantity A times B times C. Distributive property, we know that one, okay? And then finally, the I properties, identity and inverse. Let's look at addition, both of those together for addition. Identity property, A plus 0 equals A is the identity property. The inverse property, A plus its opposite equals 0. Notice the 0 shows up in both of those. It's what you add in the identity property, and it's what you get when you add in the inverse property. Okay? How about for multiplication? The identity property, A times 1 equals A. That's what I multiply by to keep everything the same. Inverse property, A times its reciprocal is equal to that special number 1. Okay? So that's a pretty good picture right there. That's a good way to summarize the relationship between the identity properties and the inverse properties. Okay, give me a 1 to 5 here. You can be real subtle, but I kind of want to know where we are. 5 meaning this, I got this stuff. 1 meaning, you know, just give me a scale. I want to know where we are as a group here a little bit. Okay, good. All right, we're getting there. And practicing this a little bit goes a long ways. Let's remind ourselves, okay, in terms of like using A's and B's and C's, let's try to just fill this in. This is a good way to remember stuff, kind of test yourself a little bit. So everybody think to yourself, what would the commutative property of addition be using A's and B's and C's? Somebody be brave. Everybody think for a second. If you want to, who has notebooks so far? Math notebooks? Ooh, not many. Remember, you have to have those post roundup. You got to show up Monday after roundup with your math notebook. If you want to, this would be a good time when I would say if you had your notebooks, this would be a great time to kind of break that out and just on a piece of scratch paper, write this stuff down. That's an excellent way to memorize stuff, is to write it down. The way your brain works, if you have to go through the process of like articulating something in writing, even just moving your hand and writing it down helps strengthen those connections in your brain. If you don't have a notebook but you want some scratch paper, I've got stuff right up here, feel free. Okay, so let's just look at the commutative property of addition. Commutative property of addition with A's and B's and C's. Some brave soul here, help me out. Throw this out. And don't be afraid to have an incorrect answer. That does not make any difference. Incorrect answers are fine. We just want to get the ball rolling here with a little discussion. So what's the commutative property? There you go, beautiful. A plus B equals B plus A. What's the commutative property of multiplication, somebody? See somebody raise a hand here and help me out. Yes, sir. A times B equals B times A. Fantastic. Okay, now take a second on your own and think about the associative properties for addition and multiplication. And just try to write those down for yourself. Okay, associative property, what'd you get? Somebody. Yes, sir. Okay, so what do I need to do to this? Okay, so I could put parentheses around it. So we call that a quantity. So A plus the quantity B plus C equals. Okay, I'm going to do it this way. That's a true statement, right? What Dylan, right? What Dylan just said is true, but here's why, like on the assignment, if you write that, it might mark it wrong, and here's the justification for that. If you write B plus A plus C, that is true. That is the associative property. But on the assignment, they want you to use only one property at a time. They don't want you to use multiple properties. So yes, I changed the two numbers that I was adding, but what else did I do with this result? I changed the order too, didn't I? Right? So I used both the commutative property here to exchange the positions of the things, and I used the associative property to change the two things that were being grouped. You see the difference? So now, what's an example of the associative property What would my answer be if I'm not exchanging any positions of anything, only regrouping stuff? There you go. Good. The quantity A plus B plus C. You see the difference? I mean, they both work. Oops. Okay, but that's the one they're looking for on the assignment. Make sense? Okay, what about for multiplication? Somebody new. Help me out here. What's the associative property of multiplication? What do you think? Associative property of multiplication. I'll get you started. What do I have to do to that? Say it again. There you go. Okay, so let's do the quantity A times B times C equals times. There you go. Good. A times the quantity B times C. There you go. So we're just changing the two things that are being grouped. Okay. Good. The identity property of addition. See if you can write that one down real quick. What's the identity property of addition? What do you think? Mr. Thatcher, what do you think? What's the identity property of addition?
I don't know.
Okay, now remember, think about this now. Identity gives it away. We want the identity to stay the same. So I got to add something to A so it stays the same.
I'll say A plus 0.
That's it. There you go. A plus 0 equals A. And again, why is that the identity property? Because what we started with is what we ended with, right? Okay, what's the identity property of multiplication? There you go. A times 1 equals A. Oh, wow. And again, notice why is that the case? Because what I started with is what I ended with. The identity stayed the same. There we go. Okay, so that's the identity property. Now the inverse property, remember when we do the inverse property for addition, what does our sum have to equal? What's it have? Was it again? 0. Yeah, exactly. Right? It has to equal 0, whatever that magic identity number was that we used in the identity property, 0. It has to equal that. So what would I add to A to get 0? Somebody who hasn't answered yet. What do you think? A plus what equals 0? Negative A. There you go. It's opposite. A plus its opposite equals 0. Okay, now the same pattern is true for the inverse property for multiplication. What does it have to equal? 1. Yeah, exactly. 1 because that's our identity number for multiplication, right? So now A times, any number A times what is equal to 1? What's that one? Okay, let's think about this in terms of, think of it as a fraction. A is the same as A over 1, right? Times what equals 1? 1 over A, exactly, right? Because I have to have the same thing on top and bottom. Right, I get A on the top, A on the bottom when I multiply straight across. Agreed? Okay. So we know that. Good? Okay, now name these properties. Let's try a few of these. What about number 13? Stare at that for a second. I'd like you to tell me which property is being used or illustrated in problem 13. What do you think? Let's get new customer here. What do you think? What do you think? Mr. Bashirs, what do you think? What's going on in 13? Associative property of addition or multiplication. There you go. That's it. Associative property of multiplication. Good? Okay, how about what's number 14? Everybody? What's going on in 14? Yeah, it's just distributive, isn't it? Look what's going on. I'm just distributing the 6. Okay, so that's just distributive. Okay, number 15. Stare at that for a second. What do you think? What is it? Yeah, inverse property of, beautiful, inverse property of addition. There you go. Inverse property of addition, and how come? Well, look, because it equals 0, right? That's our giveaway. Okay. How about number 16? Take a look at those. Stare at those for a second. What's going on there? Yeah, commutative property of, there you go, because I'm exchanging the two things that are being added. How about 17? Associative property of addition. There you go. Okay, how about 18? Inverse property of multiplication. There you go. And that's a giveaway because it equals 1. What about 20? There you go, identity. How come? Because what we start with stays the same. Identity, property of addition. 19's a little bit tricky. I mean, not so super tricky. What's going on with 19? It's distributive property. The fact that it's backwards makes no difference because I always have the option, when I have an equation, I can always take the two sides and exchange them. It still stays equal, doesn't it? Right? So again, that would just be distributive property. Okay, so how about, let's look at, okay, 21. Name the additive and multiplicative inverse. What's the additive inverse the same as? What is it? The opposite, right? Okay, so if negative 8 is the number we're starting with, what is its additive inverse or opposite? 8. What's the multiplicative inverse? Okay, the reciprocal. Good. So what's the reciprocal of negative 8? Yeah, negative 1 over 8. You might be thinking 1 over negative 8. Same thing, except we never want to leave a negative sign on the bottom. We always pull it out front of a fraction, right? How about 2/3? What's the additive inverse? What's the multiplicative inverse? You got it. No big deal, right? No big deal. Okay. Where are we for time here? Okay, this is it. We'll just do this. This probably finish it up for today. We'll look at just a little example. We want to get a little practice kind of transitioning from words to math symbols, which is a lot easier to work with algebraically, right? So how could we say, and here are some kind of, key words that we've talked about a little bit. How could we turn number 1 into a math sentence instead of an English sentence? One really key word here, whenever you see something like the word is, what does that always correspond to? Equals, yeah. Okay, so we know, here's an example where the sum of x and 5 is 20. Well, we know something is equal to 20. What's on the left side? What is the sum of x and 5? Sum implies addition, doesn't it? Yeah, so x plus 5. Okay. Number 2. 2 times the sum of 3 and y amounts to 4. What does amounts to correspond to? Again, there's your equal sign, right? It's kind of nice to look for that equal sign first, and then you can organize what's on the two sides of the equation after that. So we're going to get an equals 4. How do I say 2 times the sum of 3 and y? Okay, so I could do something like this then. Okay, yeah, I need parentheses, right? How come? Okay, because I'm doing 2 times the entire sum, right? So if the sum means all that stuff taken together, so it has to be in parentheses. So this one has to look like that. 2 times the quantity 3 plus y equals 4. Give me thumbs on that one. Does that make sense? Okay, why those parentheses are there? Okay. How about this one? The difference of 8 and x is the same as, so what's that correspond to? Equals, okay. The product of 2 and x. Okay, so we get an equals in the middle. What's going to be on the left? How do I say the difference of 8 and x? Okay, that's subtraction, isn't it? So 8 minus x equals the product of 2 and x. 2 times x or just 2x. Same thing, right? Okay. And then finally, how about this guy? The quotient of z and 9 amounts to, so that's equals, right? 9 plus z. What's the quotient of z and 9? Quotient means division, right? That's kind of one of our math words for division. So z divided by 9 equals, and then 9 plus z. That's pretty self-explanatory. Okay, good? All right. We got through most of this stuff. We'll look at maybe just a couple new things tomorrow, give you a chance to kind of work on this assignment tomorrow a little bit too then before the break. Okay, sound good?